Today, we are going to talk about an interesting topic. This is related to the application of technology to civil engineering and in particular to construction engineering. Today, we are going to talk about the implication of building information modeling or BIM for integrating the information related to the real estate projects throughout their life cycle. I think the construction industry and real estate industry is lagging behind other industries in adoption of many of the new digital transformation paradigms. And building information modeling is one of the developments that can help to bring the construction industry in line with many other industries using different types of digital technologies, because this platform provides an opportunity to integrate a lot of information and present it over different timelines, different phases of the project, and different disciplines. So this discussion was actually presented in Tech Talk, which is a series organized by AIT related to various technology talks, inviting not only people from AIT, but also from experts in the industry. I hope you find this overview of this topic interesting.
So I will start the discussion on BIM, and because this is the first of the presentation, so I'm quite sure that some of the things that you see might be also emphasized or duplicated in the following presentation, because obviously some of the core terminology and technologies are common. First of all, a little bit about AIT. As you might know, that it's a postgraduate institute, and then we do a lot of academic programs as well as research and application of knowledge to industry. And this talk today is one step towards that the work that we are doing at AIT and the work being done in our network, we share it through this platform, what we call AIT Tech Talks. And this works both ways. We learn from industry, and at the same time, we present some of the research and the development that AIT is doing. So today's topic, I am actually going to talk a little bit more on the conceptual level of how can we integrate the real estate project lifecycle information using BIM. And during this and in that discussion, we will touch upon some of the basic concepts of BIM as well, which I'm sure will be expanded more in the next presentations. So first of all, what is a real estate project? So real estate project, basically, if you look at the definition, legal definition, is that it is anything that involves a physical space or a real estate that can be sold, that can be occupied, that can be used. And this is a place where people live together, work together, or utilize it for using some common goal. So it's a very, very important piece of our society, because this is it's called it real, because this is the place that actually physically exists. And it is transferable, it's usable, and it's many of that is for a common purpose. So real estate projects can vary from a single family house to an apartment building, multi-family high-rise buildings. It could be an industrial industry or a warehouse or industrial complex, or it could be corporate centers and office buildings and so on. As you know, economy depends on real estate projects. And one of the reasons is that this has a very high cash dispersion capability. Any investment that goes into a real estate project that is distributed, just like any other infrastructure project also, gets distributed to a lot of people. And a lot of people continue to generate revenue and business from a real estate, not only during design, construction, but during operation, through resales, through rentals, and it's just a whole life cycle. It's a continuous source of economic activity. That's why this is important, the real estate. We provide this information through entire life cycle. So broadly speaking, the life cycle could be preliminary planning and design, then development, then management, and then completion. But this is only part of that. If you really go into the detail, you can see that this life cycle is pretty long. It has several steps, almost like 30 steps or more. And it may involve a location selection, initial feasibility, initial financing, site acquisition, hiring of initial consultants, then site studies, several site studies, then preliminary approvals are needed, and then we have to clear a site, then consultant engagement to do the detailed design, then more site studies, preliminary design, and so on. And it continues through design steps, through construction steps, through marketing, through sales, and finally, when the project is completed and it is delivered, it is occupied, it is also managed, facility management, or either managed by the owners or residents themselves, or managed by professional companies that have specialty. And especially these days, the real estate projects are getting extremely complex. They are no longer just buildings. Just like cars used to be a very mechanical thing where you learn to drive it. There's a steering wheel, there is a clutch, there's a gear, and then a couple of things, and that's it. Now cars are highly sophisticated piece of software and hardware combined together with so many systems running in. So buildings are going in the same way. They are becoming highly complex, and also they are becoming more sophisticated in their operation, in their usage, and so on. So this requires that we understand the entire life cycle of the project until the building is dismantled and disposed of for another purpose, or its use is changed. So there are many stakeholders, and they have many concerns about the project. For example, the information in a project is of direct relevance to the owners, developers, consultants, contractors, facility managers, residents, marketing teams, sales teams, media teams, and visitors, depending upon what type of facility is that. So one or more or many of these people will be involved during a short time or during the entire life. But let's say if the owner is also the developer and also manages the facility, then the owner has their whole lifetime of information management. And sometimes these things are transferred from one stakeholder to the other. And also we have indirect stakeholders, for example, the approving agencies, the monitoring agencies, the archive agencies, the city administration, and investors. They also influence, and they also need information about the project, not only the one which is built, also the one which is being built, so they can make some decisions. So information is critical to a large number of stakeholders in this highly complex development. And the key concerns of these people is financial concerns, branding, delivery, quality, sustainability, continuity of services, legality, safety, and well-being of people. So there are many concerns that these people have that are related to these real estate projects, because they are for human consumption or human use. And then they have many questions during the lifetime. Everybody has questions at any point, that why this happened and why it was done this way, and where did it go? Where is that item in the building? When did something happen? And when it will happen, and when it should happen, and so on. And what is it? What if this was done? And then what happened at a certain time? And then who did it? And who is somebody in this project? And then how it was done, and how much does it cost, and so on. So there are many questions, many concerns, and they all require information about the project in some form or the other, or people who have the information will need to answer that. So what is the project information that everybody is these days in a digital era accesses? This information is spread all over in all forms. This is documents, Word documents, this is images taken by cell phones, by files, by drones, by scans. These are videos, these are media files, these are drawings, these are models for structural engineering, for BIM, from MEP. These are internet-based information there. This is data in CRM, in management tools, in the project management tools, in ERPs, in SQL, in Excel, mostly Excel. It's a lot of data, lot of information is spread all over the in the form, and also in the places and time. And all this information is quite disconnected most of the time, because different people are preparing it, and different people are storing it, and different people are discarding it. And when people leave and the organization changes, the information doesn't really transfer from one to the next stakeholder, or one to the next stage. So this is the key reason why we need to integrate. Another challenge and the need is that things are getting smarter. As we know, smart homes, everything is now supposed to be controlled digitally, electronically. So if that is the case, then the information cannot be lined with the humans alone, or be with the human knowledge, or in the printed form, or in documents. It has to be digitally accessible, connected, digitally understandable, and digitally analyzed. So which means that in the real estate projects, which are now entering the smart era, the information has to be digitally managed for these things to work. And in the process, these smart devices also produce a lot of information will be put back into the system for other usage. And then we have smart cities beyond, the whole cities are now, everybody's working on smart cities. And this has the whole new era of connectivity, of information sharing, of policies, of the things which are basically no single real estate project stays in isolation. It is connected to other things like the infrastructure, like other buildings, like the other systems. So which means that the information not only has to relate to a particular project, but it also has to be shared with the other connected systems. And now also we are looking at the new paradigms for development of cities, and real estate is part of that. Green cities, sustainable cities, resilient cities, livable cities, future-proof cities, and so on. Many terms are coming up. And as we devise new paradigms, they all require a shift of the way we manage and plan and design our cities. And once again, integrated information becomes very important for that. We all hear about the bio-circular green economy these days. And once again, if we want to do that, real estate is once again an important generator of greenhouse gases and also can be a saver of greenhouse gases, and both can be ungreen or can be green. And once again, the information will govern a lot of that evaluation, management, and so on. And there have been many challenges that people have tried BIM, and it hasn't really caught on. It has to do with policies, it has to do with the ability or the willingness to share information. It has to do with adopting the technologies. It has to do with the training, the retraining of the people, and so on. So there's a lot of challenges in employing them on a project which is so complex. Some of the infrastructure projects are less complex because they're managed by one agency. So it may be possible to do that. But real estate projects, the stakeholders are changing all the time. So let's take a quick look at the BIM. There are several dimensions of information handled by BIM. There are several levels of details handled in BIM. And there are many standards and frameworks, and also there are many software and tools. And this is what makes it harder to adopt this because there's so much depth and there is so much disparity in the way the BIM is being developed and the way it is being promoted. So first of all, in terms of the dimensions, as you know, starting with the simple 2D drawings that you see in AutoCAD, going to 3D models, to models with time development over time, plus adding the cost component, then sustainability, and then facility management. And now going beyond that to 10Ds, including the safety, including the lean construction, and also the deconstruction and the decommissioning, and so on. So these dimensions and industrialization of the construction as one of the steps. So BIM itself is evolving. And as we add any more dimension to it, it requires more information to be embedded, processed, and connected. And which means that continuously, the standards have to be developed and the data has to be maintained and updated. And then is the level of detail. How much information do we put into a BIM model? And this can vary from very simple, what they call level of detail 100, to as high as level of detail up to 700, which means very detailed information about rebars, the bendings, the locations, the almost as good as the real buildings, as they call a digital twin. So that is the level of detail that the people are now trying to put into these information models. Basically, there are several attempts have been made to standardize it. And one which has really survived several cycles of development is the IFC, which is the Industry Foundation Classes, which is a text-based system to describe very complex objects with a hierarchy and relationships and so on. And this standard has been quite stable and has gone through several iterations already. And the second one is the BIM collaboration format, which is an XML-based format, which is also developing to create how we can collaborate between various BIM components. And then based on these standards, open systems have been developed, for example, Open BIM for bridges, Open BIM for buildings, and so on, and many others. And there are proprietary systems, specialized systems, which are used by particular software developers. So they have their own internal data structures and mechanisms to create a model, but they can still communicate with each other by exporting their data to the industry exchange formats like IFC or BCF and reading the information back. And this is one of the ways that various software can talk to each other. That's why there is a great drive or movement right now to go towards open BIM, which means that everyone can share whatever software they have, they can share the information through the standard centers or standards and through open BIM. So this Building Smart organization has been working on it for many years, and they have developed the open BIM platform, which is based on IFC. And there are many people, many companies, many developers are joining this. And a lot of people think this is a great idea because it's kind of open and it's open source. So it's if anyone can access this file format. So the closed systems are where they basically each organization have their own files and only they can read it. But if it is, if they can all communicate through the common standard, which is IFC, for example, then open BIM system can work and then everyone can communicate. And this is where the real collaboration strength lies for BIM, or this is where the integration of information can be done, because no matter who is developing the BIM model, as long as they can export in the proper manner to the IFC or the open BIM, then it can be utilized. Coming back to the information, as I mentioned, information or the data that we have is diverse. And the problem many times is that they are not connected to each other. It's hard to correlate one file with the other file, one column in a database to another in another file, because we do not have a common connectivity. And if we have a BIM model of a building complete, and then we can connect them through a physical entity. So for example, all of this data, if it can be connected or referenced to one particular beam in this building, then we have a huge opportunity to integrate this information, because now they all at least point to a physical entity. And then once we gather all the data, clean it up, connect it together through referencing or whichever mechanism we use, then we should be able to get a full information, integrated information about that beam and through its connectivity to the columns and to the slabs and so on. So this is why BIM has that potential, because it is just like GIS, it's connected to something which is real, which is spatial, which can be seen, which can be visualized. And if we can have a proper connection referencing system, then this will become very useful. So BIM can be used to connect the material prices, the skilled labor, the design and planning phase, the scheduling, the changes during the construction, architectural rework, monitoring of the work, any defects that we are having, any conflict on the site. Then we can do all of, through integrating all the information, we can do cost management, facility management, construction management, and project management. So basically, all the information once available here in a common framework, then many applications of that information can be built, or many management tools can be devised that use that information and make decisions, while using the common kind of authenticated or verified information. And that I think is the strength that we are all talking about in this. BIM, if BIM is as the basis of maintaining the project lifecycle information, then it can take this information not only in terms of connectivity with each other, but also connect over the time and over the phases and over the stakeholders, so that when the information is gradually built up, we track who did it, when they did it, and what stage was that, and so on. So from that perspective, then we can go the whole cycle, that the design, built, and operate information can all be integrated through a properly developed BIM framework. And any tool can be used. So it could be Tekla, it could be AutoCAD, I mean, it could be Revit or any tool, or it could be an open BIM based system. The important thing is to make sure that the information is in a standardized form where they are related to each other, where they are connected to each other, where they are referenced properly, they are categorized properly, and so on. So documentation, fabrication, construction logistics, operation and maintenance, uh, renovations, everything can be linked right back to design and from to the concept design. So this is how many people have been developing this life cycle approach to the BIM information. And many times to implement that, we can have a cloud server. These days it's possible because that provides us a common storage area for the information. And then that cloud can access the information from various sources, even Dropbox, Drive, all of those, from Amazon services, from programs like ETAP, SAP, and AutoCAD, and others. Through the API, information can be extracted, relevant information, and then cleaned up and stored into a server using the standard formats that I mentioned. And then on top of that, then the client or software can be developed to access and process and visualize that information. One example that we recently, the company also discussed with us in AIT, is a company called Site from Spain. And they have developed a similar system based on OpenBIM. They are able to connect many of the information through the life cycle, through several stages and several stakeholders. And this is one of the examples. There are many where something like this is already being utilized or already being developed. Another concept these days that we are also going to hear in the following presentation later is the digital construction twins, or digital skins as they're called. That means the entire project has a completely digitally created model, and it is simply connected and updated as the construction goes on. And it takes information from the sensors, it takes information from the construction progress reports, takes information from images, and so on. It's a site and a digital site which just are living side by side, and both are updated at the same time in real time. And by the time the project finishes, then we have as-built model of the whole project. If everything goes well, that is the ideal situation. But what we're talking about is that we also have to have information before the construction started and after the construction is finished. So this can be transferred to the people who will manage the building. And also it takes information before the construction started. Similarly, the safety of the workers these days through IoT, through sensors, can be connected to these systems. And once again, this is another level of detail or level information that I mentioned in the BIM, which is safety, can also be now integrated using a lot of these sensors and wearable devices that construction workers may be wearing. There are many good references on it. This is one of the paper that I just want to refer, because this paper goes into detail on how this can be done in terms of actually defining or identifying the IFC classes that will be used, and how through, for example, a construction site, various documents and various reports can be brought in, connected to a particular physical entity. So this is a good paper because it gives a detailed explanation and a framework on how it can be done, what we are describing, that how we can combine multiple information in various formats back to a physical model through IFC as a layer. So if you are interested on developing or understanding this paper that I mentioned here is a good one. Then many softwares these days are actually implementing some form of IFC and BIM integration, whether they go to directly tools or they go through IFC. So for example, the products developed for structural analysis for buildings, because most of the real estate projects you do need structural design and structural analysis. So CSI, which is one of our partners for this event today, because they have set up a CSI BIM lab at AIT, supported by them. So we do some work with them, and they have used IFC to connect to third-party tools, as well as to their own system like CrossCAD and CrossRevit to connect to specific software tools. Once again, with the attempt to share the information and integrate information. We know IoT, I mentioned these days, there's a lot of talk on that. And once again, if we have a digital model, let's say in the BIM format, then connecting to IoT is easier because IoT information generated by IoT sensors is for a physical entity. So if we have a BIM model which also receives this information, then that information can become further enriched. BIM can, we can take the same concept beyond simply taking the information from documents and so on. From the drone imaging and from other visuals, we can also construct models which can then be compared with the BIM models for many purposes. Because these days, the drone and even other images can be converted to 3D representation, 3D models. And if they are in 3D and the BIM is also in 3D with a different level of detail, then there should be possible to superimpose those models and then compare the differences and so on. Or backtrack and develop the analytical models from physical models. This is one example where a drone image or drone model was brought back into a structural model for analysis. And this could also be brought back to create or update a BIM model. Like in this case, the BIM model is here, and then the drone images from a construction site are here. And then by volumetric comparison, the difference or the progress could be monitored. This is more feasible for infrastructure projects, less feasible for tall buildings in a congested city where most of the construction site is hidden by claddings and by other safety measures, or where drones may not even be allowed to fly. Another use of drones could be the information coming from sensors installed on building monitoring or infrastructure monitoring. And once again, they could be connected to the BIM models, and BIM models are connected back to structural models. So we could take this information all the way back to analysis and then update the structural models based on that information. Another one is the image-based inspection monitoring of buildings. So we can take the images, and then images can be analyzed through AI to find defects or cracks, and then that can be compared with the BIM models to locate where that crack happened, on which column or which beam, and whether it is severe or not severe. So a lot of downstream tools can be developed based on a well-documented and well-developed BIM. IoT is one way of sensing, but there are also building monitoring sensors which are installed, especially in infrastructure, but also many times in buildings. Like, for example, accelerogram installed in many buildings. Then that information can be brought back to connect to BIM, to structural model, reanalyze, then determine the damage of the structure or non-structural damage that might happen, because this BIM model also has architectural information, including the finishes, including the type of the partition walls, the type of the false ceiling used, because in most cases in structural, like earthquake, for example, or strong wind storms, it's the non-structural things that get damaged. And most of the time that information is not present in structural models. But if this information is connected through BIM, then the same system that does the structural analysis can also go one more step and do a non-structural assessment of the building as well, which is more realistic than only doing a structural evaluation. All of this system could be developed around cloud-based models that I mentioned again, and then connect them to sensors and so on. So once again, another aspect of the life cycle during operation, during hazards, during earthquakes can be evaluated. Another important discussion, how can BIM and GIS workflows be integrated? Because GIS has been there for a long time. Successfully, it has become a de facto modeling tool for presenting information on a geospatial scale. And people present all kind of information on those maps and multiple layers, and people can combine and analyze so many things. So if we also connect it to BIM, then a greater level of information can be developed and represented and shared. So there are several benefits of doing that. The main takeaway from this discussion is that in a BIM and IFC, we have an opportunity for integrating the life cycle information for a real estate project. And like I mentioned, real estate projects are quite complex in their nature because, first of all, the stakeholders are very diverse. And it's not like one agency or one client has the total control on the project. The clients, the developers, the contractors, the designers, the owners, the building managers, even the renters and the people who visit, they have diverse needs and they have diverse interests during the lifetime. So if the information is organized, is collected, is integrated, is cleaned up, then this information can be of value throughout the life cycle of the project. And this could help not only a particular project, but it can also connect to the infrastructure models, and it can also connect with the city official systems, and it can connect to emergency response systems, and so on. So the opportunities for using this information are quite extensive, and especially it can also be used for green initiatives, for sustainability studies and monitoring of the buildings. So with that, I would like to thank everyone, and I hope that we will have even more interesting presentations coming forward.